Welcome back. Let's continue our discussion on a brand new topic, and that's quadratic equations. Um, if you remember, when we did learn the concept of factoring, we did learn a little bit about quadratic equation, but I figured if I dedicate entire series of videos to the topic of quadratic equations, we could actually explore the concept from a variety of perspectives, and that's the point. So without further delay, let's get started. The first problem is actually quite straightforward. So we have x squared plus 6x plus 9 equals 0. So when we multiply the x squared minus 9 squared, 9, we get 9x squared. So we should multiply the two terms, we get 9x squared. Should we add the two terms, we should get 6x. It's quite straightforward. If you multiply 3x times 3x, we get 9x squared. If we add 3x plus 3x, we get 6x. So we substitute the 6x with 3x plus 3x, and that'll be x squared plus 3x plus 3x plus 9 equals 0. So if we split this equation right here into two halves, and in the first half, if we take x as a common factor, then we get x times x plus 3. In the second part, if we take 3 out as a common factor, then we get 3 times x plus 3. So if we combine the x plus 3 and then we leave the other term as it is, then we get this new expression that's equal to 0. Since both the expression contains x plus 3 equals 0, x is equal to negative 3. And that is it. Right? Now, because every term in this particular expression is positive, we do not have to worry about the positive and the negative aspect that is normally confusing to some people. So let's look at the next problem. So we have 64x squared plus 24x minus 10 equals 0. Now, what I normally advise when you have large numbers for x or the coefficients, I suggest, if it's possible, reduce them to the next simplest form or whatever the simplest form is. The term that's common in all of this is 2. So if we take 2 out, then we get 32x squared plus 12x minus 5 equals 0. Because these two terms equal 0, we can eliminate 2 from the expression. We no longer need it. So if we factor this expression that's inside the bracket, then we can determine the value of x. So we get what? Negative 160x squared. So we should multiply two terms, and that'll give you negative 160x squared. But when you add the two terms, you get plus 12x. Well, ends with a 0. So normally if you use factors of say 20 or 2 or 10, then you get 160, right? So if we do plus 20x times minus 8x, then you get negative 160x squared. When you add the two terms, okay, then you get plus 12x. And I've repeatedly said, where the plus or minus goes depends on what you want. In this case, we want a positive 12x. So we have to put the positive with the higher number. So when we subtract the 2, we get the positive with the higher number. So now we substitute 20x minus 8x in place of 12x. So that'll get us 32x squared plus 20x minus 8x minus 10 equals 0. So if we split this equation right here into two halves, and if we say take in this, the maximum we could take would be a 4. So if we take 4x out of the bracket, then we get 8x plus 5 minus here. Well, it doesn't look like much, but if you actually take, sorry, 4, 8, yeah. If you take, oh, sorry, this would be 5, right? Because we changed it here. So it's no longer 10, sorry. So if we take negative 1 out of the bracket, then we get 8x plus 5 equals 0. So if we combine the two terms, it's 4x minus 1 times 8x plus 5 equals 0. So 4x minus 1 equals 0, x equals 1 over 4, 8x plus 5 equals 0, 8x equals negative 5, x equals -5/8. I mean, this problem is not difficult by any real extent, but you just have to figure out what the two terms are that you could use to figure out the positive and the negative root. So let's go to the next problem. This problem is very simple, but it's long. There is no easy way around this problem, okay? So the question asks you, all of the following functions have exactly one root except. So let's assume each of these f of x value is equal to 0. So let's start from the bottom up or from the top up, it doesn't matter. So, or you can start from the middle. Let's start from the middle. Okay, this equals x squared minus 2x plus 1. So we don't want two roots. We only want one root for all the expression, the one that offers you more than one root, that's the answer, right? So x squared minus 2x plus 1 equals 0. So if you multiply, we get x squared, right? Right? Whereas when we add or subtract, we should get negative 2x in a way. So which means if you add minus x plus minus x, then you get minus 2x, right? Whereas when you multiply minus x times minus x, then you get x squared, right? So if you substitute x squared, and in the minus 2x place, if you substitute minus x plus minus x, then we get minus x plus 1, right? Equals 0. If we split this equation right here and take x as a common factor, and here we take minus 1 as a common factor, then we get x minus 1 times x minus 1 equals 0, x equals plus 1. So this is not what we want. We want something with more than one root. Let's go ahead with the second term from bottom up. So it'll be f of x equals 4x squared minus 4x plus 1. 4x squared, this is equal to 0. So we want 4x squared positive, but when we multiply two terms, we get 4x squared, but when we add or subtract, we get minus 4x. So if you take minus 2x and you multiply by minus 2x, we get plus 4x squared, which is what we want as far as multiplication goes. But at the same time, when you also add them, then you get negative 4x. So if you substitute negative 4x with this, then you can rearrange the expression as 4x squared minus 2x plus 1 equals 0. If you take 2x out of here, then you get 2x minus 1. If you take minus 1 out of here, then you get 2x minus 1 equals 0. 2x minus 1 times 2x minus 1 equals 0. X equals plus 1/2. Again, this has only one root, so that is not possible either. Let's go up to the top, okay? 1 over 4x squared equals, so f of x equals 0, right? So 1 over x squared plus x plus 1, right? So this is equal to 0. What if we take the whole numerator to be, the denominator to be 4, then we will get x squared plus 4x plus 4 over 4 equals 0, right? All I did is I took the denominator to be a common factor of 4. 4 times 0 equals 0, so x squared plus 4x plus 4 equals 0. Again, this is no different than the problem before, so I don't want to go further into expanding. It's what we get, right? So if we take x plus 2 times x plus 2 equals 0, x equals negative 2. So this is also incorrect. We're down to just the 2. Okay, so let's do the one below the top one. So we get minus x squared plus 6x minus 81. This is equal to 0, right? So if you just like we did in the previous case, if we take a common factor of 9, then you get minus x squared plus 54 minus 81 times 9 is 729, right? Equals, this is x, of course, equals 0, right? If you multiply the whole thing by negative, then you get x squared minus 54x, okay, plus 729 equals 0, okay? So this can be solved further, okay? There's a lot of ways. I think it's 27 times 27. If you do that, you get 729. So if you rather think about this, it's basically x squared minus 27x minus 27x plus 729 equals 0. If you split this right here, then you get x times x minus 27. Minus 27 would give x minus 27 equals 0. That means x minus 27 times x minus 27 equals 0, implies x equals 27. Well, if all four of these only give a single root, then the fifth one obviously should give you 2 roots. I don't want to go into solving that problem because that's going to take a little bit of time, but you can take my word that one does not offer a single root. If you're curious, go ahead and solve the problem and leave what roots did you get in the comment box below. All right, let's go to the next problem. The difference between a number and its square is 72. What is the number? Well, we don't know the number. So let's assume the unknown number to be x. So the difference between a number and its square. So the square of the number is x squared and the number is x. So the difference between a number and its square, this is how it literally reads, is equal to 72. So that means x squared minus x minus 72 equals 0. So how do we get negative 72 squared? Well, we also should only get x. So that means 8x, negative 8x times positive 7x should give you negative 72, 9x times 8x, 72x, right? Squared. So at the same time, if you add 9x, negative 9x plus 8x, then you get negative x. So if you substitute this back in the expression, then we get x squared minus 9x plus 8x minus 72 equals 0. So if we split this right here, we take x as a common factor, plus 8 would give you x minus 9. So x equals negative 8 and x equals plus 9. Well, negative 8 is not given as an answer choice. Had it been given an answer choice, then obviously 9 wouldn't have been given. But because negative 8 is not given and plus 9 is given, plus 9 is the answer choice. Okay. X squared minus 6x plus 9 equals 0 and x dot k equals 1. Find the value of k. So if we find x, then we put it into this expression, then we can get the value of k. So let's solve this quadratic expression. X squared minus 6x plus 9 equals 0. So if you take negative 3x times negative 3x, then you get plus 9x squared. But when you add the two, then you get negative 6x, right? So it'll be x squared minus 3x plus 9 equals 0. So if you split this right here, and if you take x as a common factor on the first part and negative 3 as a common factor in the second, then that'll lead us to x minus 3 times x minus 3 equals 0. So x equals plus 3. So now we know x equals 3. Then if you put it in the expression x dot k equals 1, 3 dot k equals 1, k equals 1 over 3. Isn't that easy? It's very easy. All right. This will be, these two problems will conclude the first part of the video. We have more problems that will come up in the successive videos. So which of the following is a root of the function f of x equals 2x squared minus 7x minus 4? As always, you assume f of x equals 0, which makes your life simple. That means 2x squared minus 7x minus 4 equals 0. So this would be negative 8x squared is what you want, right? So when you multiply two terms, you get negative 8x squared, but when you add or subtract, you get negative 7x, right? So all we have to simply do is negative 8x times plus x will give you negative 8x squared. At the same time, when we add these two terms, we get negative 7x. So substitute negative 8x plus x in place of negative 7x in the above expression, which will give us 2x squared minus 8x plus x minus 4 equals 0. So if we split this right here, then we get 2x means x minus 4 plus 1 is a common factor outside that equals 0. So 2x plus 1 equals times x minus 4 equals 0. So x equals negative 1/2 or plus 4. Easy, right? All right, let's look at the last problem. So 4x squared plus 28x plus 24 equals 0. As I said before, if you seem like it's going to take you a while to figure out what the two components are, because these numbers are large, you can always factor and reduce them to a lesser version. So if you take 4 out of the bracket, then you get x squared plus 7x plus 6 equals 0. Because these two terms equal 0, now we can strike out 4 from the expression, which leaves us with only what's within the bracket. So let's solve this quadratic expression. So we need 6x squared, but when we add or subtract, we should get 7x. How do we go about doing that? Well, if you take 6x times 6x, then you get 6x squared. Whereas when you add 6x plus x, then you get 7x. So we substitute 6x plus x in place of 7x, which would give us x squared plus 6x plus x plus 6 equals 0. So if we split this right here and we take x as a common factor, then you get x times x plus x. Plus there's nothing to take out here, so let's take 1 as a common factor. Times x equals 0. So x plus 1 times x plus 6 equals 0. X equals negative 1 or negative 6. Okay, I've done enough problems to help you grasp the concept of quadratic equation and how to factor a quadratic equation. While all of these problems involves only a mathematical expression and then doesn't involve any word problems, because that's where I want to be on the first set of videos. So as we go through this concept into successive videos, we would see how this concept translates into different areas and how we can solve those problems. All right, so stay tuned for more videos on the concept of factoring quadratic equations.